Let's talk about binomial distribution, and the easiest way to define it is by saying that it's a combination of n Bernoulli trials with a probability parameter p. Think of a Bernoulli trial as a coin toss. It's one of the kinds of Bernoulli trials where probability p happens to be equal to exactly 50%. So let's say we have 3 coins, and we can have an outcome where there's 1 heads and 2 tails. So the outcome of this Bernoulli distribution would be 1. This binomial distribution would be 1. 3 Bernoulli trials, right? 1 rendered tails, another one rendered tails, and the third one rendered heads. And in total there was 1 heads. How do we model it? We model it with a binomial distribution. The number of Bernoulli trials is n. The number of outcomes we were expecting is k. So if in the case of coin tosses, this would have been the number of heads in n Bernoulli trials, n coin tosses. P would be the probability parameter of each Bernoulli trial. So this probability of k outcomes is equal to the following equation, where the first term is a binomial coefficient. It's standardly written like this, and then you multiply it by p power k and n minus p n minus k. So think of it this way. Let's say we have tails, right? So we said we will designate heads as 1 and tails as 0, right? So if you get k heads, then you take probability and power k. In n trials, if you got k heads, which means you get n minus k tails, so you take probability 1 minus p, which corresponds to tails, and power to n minus k. That is the probability of this combination of k heads and n minus k tails. How do you write down what is this binomial coefficient? Well, you can write it down as follows, right? It looks a little complicated, but it really is not. All it has is n factorial divided by k factorial and n minus k factorial, right? K factorial, n minus k factorial, and the factorial itself is the product of 1 by 2 by 3 and so on up to k, factorial k. So let's look at an example of 2 Bernoulli trials, right? Which means we have 3 possible outcomes: 0, 1, and 2. 0 heads, 1 heads, maybe 2 heads. If we work out the formula, it renders us 1, 2, and 1. These are the binomial coefficients. If we add them all together, right, all 3 coefficients, we should get 2 power n. Let's see why. Let's say we have n trials, right, and maybe coin tosses. Well, in this case, in each toss you have either heads or tails. And then in the second toss, again, you have heads or tails. So you had 2 possibilities in the first and 2 possibilities in the second trial. So in 2 trials, you would have 2 by 2. In 3 trials, you have by 2, and so on. It works out to be 2 power n. Why is it 2 power n? We can see also from this formula. If it's a fair coin where probability of heads and tails is exactly 150%, sorry, okay, right? It's a fair coin, probability of heads is 50, probability of tails is 50, so p is equal 1/2. Then this formula for a probability of an outcome of k heads out of n trials works out to be what? C this binomial coefficient divided by 2 power n. It's very easy to see from if you plug it to this formula. Well, in this case, it turns out that the sum of ck's, because if you add up all the probabilities, they should add up to 100, right? All if you plug every k possible and then add them all together, it should add up to precisely 100%, and it will. All right, so you see 2 power n of n trials, and in numerator you'll end up with the sum of all the binomial coefficients, and that's why the sum of all binomial coefficients should be equal to 2 power n, so that the sum of all the probabilities will work out to be exactly 100%.